Alright, so we're going to go ahead and do number 26. So I have f of x equals the cube root of 3x plus 4. And they tell me g of x, so we have two functions here, x cubed minus 4 divided by 3. And they want us to verify if the following are inverses by using composition of functions. So we have to use a method of composition by functions because they asked us to. And they specified that we need to use this method. And so what they're asking us, guys, is basically do a little mini proof. And your work is very important because our answer should be x. The little mini proof says that f of g of x, right, when you do the composite, you plug the g into the f function, it must equal g of f of x, and that's where you plug in the f into the g. So when you plug the g into the f and the f into the g, they should equal each other, and not only do they equal each other, they need to equal x. And the reason they do that is because our graphs, that is the definition of an inverse. It is an inverse because it reflects over the line y equals x. That's where that x comes from algebraically. So when we had x cubed, right, it looked like this, and the cube root of x looks like this. You can see here they reflect over each other. So let's do this two parts. So I'm going to go ahead and do f of g of x first. So I'm going to plug the g function right here, this guy, into the f function, so right here to this x. So it's going to look like this. You have the cube root of 3 times x plus 4, all underneath the radical. And so for my x, instead of writing x, I'm actually going to plug in this g function here. So I get x cubed minus 4 over 3. And this is all underneath the radical. Now I need to simplify. So what I'm going to do is I'm going to go ahead and write this over 1, because I like to keep my fractions in line with numerators and denominators. And so right here, since we're being multiplied, I'm going to simplify the inside first. Since we're multiplying, right, I can go ahead and cross cancel because 3 divided by 3 gives me 1. So these guys will cancel, and it's really important that we show our work because that's part of the mini proof. So then I'm left with the cube root of this left over, x cubed minus 4 plus 4, like that, all underneath the cube root. So my next step here is what's going to cancel order matters is our 4's. Right, so then I get the cube root of x cubed. And then the last thing, when you have the cube root of x cubed, these guys cancel. So I'm just left with x. And so that is what we wanted. So that's the first part. We're done. We proved that f of g of x is x. And that's great. But that's only half of our problem, right? Now we need to show that g of f of x is also equal to x. So I'm going to go ahead and now see if I have a different marker. I'll just use black. I want to now plug this guy right in here for x. So it's going to look like this. So we have x cubed minus 4 divided by 3. And for here, I'm going to plug in this guy here. So I have the cube root of 3x plus 4. So order matters, guys, and how we simplify. So right here, I can go ahead and simplify this. We have the cube root cube. All of this is being cube rooted, and the whole thing is being cubed, so that's going to cancel. So I have 3x plus 4 drops, and then what's left over, I have a negative 4 that comes back. That's all divided by 3. So then, order matters. What cancels next? We have our 4's are going to go ahead and cancel on the numerator. I cannot cancel those 3's yet. I have to do the 4's. I have to add and subtract those guys. So now I'm left with 3x, 3 times x over 3. And then, our 3's now can cancel, so what are we left with? X. So this guy also works. So we proved that f of g of x is x, and we also proved that g of f of x equals x, and so they both equal x, they are inverses. And again, your work is your proof, guys. It's not just this, it's the whole thing. That is the answer.